Today we're going to begin our discussion of lines by talking about slope. We're going to be on the computers 2 days this week. I'm pretty excited about the explorations we're going to be working on. So if you like using your own computer, I believe it's going to be Tuesday, Thursdays. If not, then that's okay. We'll have laptops available for you. So the slope is generally denoted by the variable m, and it describes how steep a line is. If you're talking about positive values, the steeper the line, the higher the slope. When you're driving around in very steep areas like Colorado, where there are mountains, they actually describe how steep the road is using what's called the grade. And they'll say something like the grade is 15%. And what they are telling you is the slope of the road in that area. So they're saying the slope is 15 over 100. They just use percent form for that. So slope is used in everyday life, not so much in Wisconsin because we don't have mountains here, but it is used when you drive on very mountainous roads because they're worried about runaway cars and runaway trucks also using their brakes. So they want you to know how steep it is. If you have an incline, slope is positive. And if you have a decline, where you're going downhill, slope is going to be negative. And slope, depending on how it is presented, is given as the rise over the run. But I actually have several different slope equations that are useful depending on the information that you're given. Because you can find the slope given a graph, you can find the slope given a table, you can find the slope given a real-life situation, you can find it given 2 points on a line. So the slope can be found given many different types of information. So we're going to practice that today. So this is a slope. This is a line that's going uphill. So when you picture yourself putting a little biker on the slope, you can tell the bike, if you put the bike on the lower left-hand or the left-hand side, you guys can tell the slope is going uphill. Let me use boots here, sorry. This is an uphill slope. And you see they're very safety conscious using the helmet there. So here's our uphill slope. So since the slope is uphill, we know this is going to be a positive number. We would have to actually count some squares to know the exact number, but we know it's going to be a positive number. This, we can tell our biker is going downhill. This is actually pretty quick downhill. So when we calculate the numeric value of the slope, this is going to be a negative number. I want you to notice that all these lines are straight. That is where we apply the vocabulary word slope. We're not going to stick with straight lines all year because, let's face it, they get boring after a while. But slope only applies really with straight lines. Here is another straight line down here. This is our boring bike ride. Okay, we're just going straight. So what do we think the slope of this line is going to be? Yeah, this is neither uphill nor downhill. So this slope, we actually know the exact value of this. This slope equals 0. So no calculating required. The boring bike ride, the flat bike ride, flat line, is a slope of 0. So think of throwing that bike on there. That's our very boring bike ride. And then we have this bike ride. That looks great.
did with your cat biker.
This is a rough one. Okay, I've been mountain biking before. I thought that might happen to me. The ledge was very, very close to me. So this is just kind of biking off a cliff. DJ?
It's no solution. Right?
Close. What do we call the slope of a vertical line? It has a special name. We don't write no solution. Okay, here's our zero over here. That's not the same thing. This is a nice casual bike ride. This is a rough day. or your death.
Was it like 100%?
100%? I mean, you could kind of say that, but what we say is that the slope is undefined.
Oh, yeah.
So when you think about an impossible bike ride, a bike ride that really is not one where you would survive, especially if it was a long cliff, this slope is undefined, and you'll see numerically what happens when it's undefined, because all these end up being numbers. This number we know slope is 0. This is going to be a positive number, negative number. This is slope is undefined. What happens, do you guys know what happens numerically when we get an undefined number? Yeah, so what happens, like what operations are we doing with what numbers when we get a number that's undefined?
It's going to be repeating.
All right, well, we'll see. We'll see. All right. So now we're going to talk about calculating the slope. And we're going to be doing it in a couple different settings. So in this setting, we have a graph. And so when you're given a graph, and in this graph, they actually point out 2 points for you. That might not necessarily be true. If they don't point out 2 points for you, you just want to find 2 points that you know exactly, so that the grid marks go through exactly. So rise over the run, this is the way it works. You're going to want to pick the point on the left side, and you want to count how many squares you have to rise up to line up with your other point. That is your rise. So what's our rise there? 5, okay, let's do it. 1, 2, 3, 4, 5, and then we're running to the right. We're always going to run to the right. That's a lot of arc sounds. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our rise is 5. Our run is 9. Can we reduce that fraction at all?
No.
So our slope is 5/9. Is that a positive quantity? Is the line going uphill? Yeah. So if you picture your little biker down here, he's going uphill. All right. So if you always want to place your biker on the left-hand side, you read left to right, you also analyze your graphs left to right. So he's going uphill, so therefore the slope must be positive. So when you're looking at a graph, you're going to look at how many spaces you rise, how many spaces do you get to run to line up to your next point, and that is your slope. Questions on that? That's how steep the line is. Is this slope going to be positive or negative, everybody?
Negative.
Yeah. And so you always want to start with the point on the left side. Now to line up with the other point, you go 1, 2, 3 spaces, but now it's 3 spaces down. 1, 2, 3. So that means our rise is -3 because we're actually falling instead of rising. So we rise -3, we run 1. So our slope is -3 over 1, or just -3. Yes?
Wait, so the run would always be positive?
the bottom is always positive.
There's a video on slope. It's called Slope Dude.
Slope dude.
And you watched it in middle school. It's good. It's like straight, it's something like 3 minutes. And
Slope
just,
Dude.
yeah. Watch it.
Okay. Now, okay, so far, we have looked at finding slope on a graph. And finding slope on a graph, we looked at rise over run. You can also be asked to find slope given coordinates. Given coordinates, this is the equation that you're given. And so if you're given 2 points, one point has the coordinates x1 and y1, really the 1s and the 2s are assigned just haphazardly. It doesn't matter which you assign to be point 1 or point 2. It's just one of the points has x1 and y1, the other point has x2 and y2. And then you're going to subtract the y values and put it over the difference of the x values. Because the rise represents the change in the y's, because the y change is vertical, and then the x change is horizontal. All right. So this is used when you're given coordinates. So this is the equation when you're given coordinates. And then this is the equation that you use when you're given a table. But really the ones I like to focus on are the table one and the graph one, because the coordinates one, it's very easy to mess up whether things are positive or negative. So I'm going to kind of show you how I make everything into the first or the last equation instead of the middle one, because the middle one people mess up. But it's all the same concept. Just depends on how the information is presented to you. Whether you're given 2 points, whether you're given a graph, or whether you're given a table of values. So a common question is they give you 2 points and they ask you to find the slope. And so what you're going to do first is assign one of the points to be 0.1 and another point to be 0.2. Doesn't matter which you pick. And then in 0.1 you have an x value and a y value. So since it's 0.1, this is x1 and y1. Since this is 0.2, this is x2 and y2. Right? So you're going to assign your values for x2, x1, y2, and y1. Then you have the slope equation, and again we use m to denote slope, and it was y2 minus y1 over x2 minus x1. The difference in the y values, x2, wow, that would have been 0, would have been not correct, thank you. So there we go. The difference in the y's over the difference in the x's. So now I'm going to substitute in my values as I assign them. So it is 5 minus 2 over -3 minus 4. So in the numerator I get 3, and in the denominator I get -7. My slope, generally I don't want to leave the negative in the denominator, it just looks weird down there. So I'm just going to call it -3/7. So as I said before, I don't love using the slope equation. That's y2 minus y1 over x2 minus x1. So I'm just going to show you how I do it. The way I do it is I create a little table, and I just put my points in a table like this. And then what I say is I say, okay, how are the y values changing? By 3. And how are the x values changing?
7.
Up or down?
Negative.
Down 7. So the slope is the change in y over the change in x. In other words, 3 over negative 7. So I like using the table because then I'm kind of showing the movement of the points instead of, I know you're still doing the same operation, but it's like, oh, this is going up 3, this is going down 7, so it's a change in y of 3 over the change in x, which is 7. So 3 over negative 7 or negative 3 sevenths. So when I do slope, even if they only give me 2 points and I'm not given a table, I just create a table because I find it faster, and a lot of people tend to get the subtraction wrong when they do it that way. This way they get it right more often. So when I show it, I'm going to show it doing the table, but if you guys prefer the equation, that's completely up to you. Any questions? So for this one, we have negative 4, 8, 6, 7. So how are the y's changing? Is it up or down? So negative 1. And how are the x's changing? 10. So the slope is change in y over change in x, so negative 1. Yes. No, I'm going to keep doing it because once people get this part down correctly, the second mistake they do is they put the x's on the top. So I just want to make sure you're not going to be putting the x's on the top because that is wrong all the time. So you have to put the y's on top. So I'm going to put this up there as a reminder to you to put the y's on top. I don't care what work you show, okay? Because well, I shouldn't say that out loud. You should show some work. This is not required though, because if you know that off the top of your head, that's do you know offhand what the slope of that line would be? What is it? It's undefined. So if you think of the bike ride, you know the answer right away. So I am going to encourage you to just write the answer down, because honestly, the more work people do for these problems, the more likely they're going to get it wrong. So if you look at it, you say, oh, that's that suicidal, that bike ride off the cliff. That's undefined. Then you get the answer right every time. But if you were to go through the process, let me show you why it's undefined. Who can tell me the coordinates of the point Q? DJ? 2, 2. And who can tell me the coordinates of the point P, Denise? 2, 6. So if we were to put these points in the table, the change in y is down 4. The change in x is how much? None. It's 0. So change in y over change in x is negative 4 divided by 0. Is it here? Try your calculator. Type in negative 4 divided by 0.
It says error.
It says error. You're asking yourself, how many times does 0 go into negative 4? It doesn't. It doesn't. This is undefined. You cannot divide by 0. You can't. 0 divided by negative 4, you can do all day. That's 0. But negative 4 divided by 0 is undefined. DJ?
What if, so why is it 0 and it's a flat line?
Okay, so if it's a flat line, like this, let's identify these points. So DJ, what is this point?
0 and -3.
And what's this point?
5 and -3.
Okay, 5, negative 3. Okay, so let's put those in a table. 0, -3, 5, -3. TJ, what's the change in y?
Or 6. Wait, 0.
0. What's the change in x?
5.
5. So the change in y over the change in x is what, TJ?
5, 0,
0 over 5. What's 0 divided by 5?
0.
0. So 0 divided by 5 is 0. Is undefined. So this slope is 0. And you didn't need any math to do that, so you don't have to go through the arithmetic. But the reason it is 0 is because the change in y is 0. 0 divided by any number is 0. Whereas over here, any number divided by 0 is undefined. Because you can't put 0 into anything. It doesn't work. It's like, let's divide this pizza up for 0 people. It doesn't make any sense.
Well, you just don't put it in.
Why buy the pizza?
Yeah.
It's just getting cold.
I'll do
Now, let's talk about using slope to graph a line. Now, graph the line through the point 2, 1 with that slope. So this is not finding the slope, but now using the slope. Yes.
So for now, so would you plot 2 and 2, 1, and then you just do rise over 1?
Yes.
So like 2 and then rise up big and then 1, 4, and then you have your second point.
Yes. Ashley, you got your hand up?
Oh no.
Okay. So first, we're going to deal with our point. 2, 1. Here's our point. Now the slope gives us the rise over the run. So this says rise 3 and run 4. So please look up, everybody. From this point, I'm going to rise 3. It's kind of like one of those pirate maps where you have a little dot, 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 dot. So I'm going to rise 3, 1, 2, 3, and then I'm going to run 4. When you run, you always run to the right. Run right. It's like RR. 1, 2, 3, 4. Done. So rise 3, run 4. Let's say you wanted another point, so you have a straighter line. You can do the opposite. So the opposite of rising 3 is falling 3. 1, 2, 3. The opposite of going right 4 is going left 4. 1, 2, 3, 4. So you can just reverse the whole thing. Okay, so I went 3 down, 1, 2, 3 down, and 1, 2. It's a little high there. Okay, because just like 3 divided by 4 is 3/4, -3 divided by -4 is also 3/4.
And yet, it's one above, you were right before.
That's right before.
Yeah, you put the,
1, 2, 3, oh.
you just went too far down.
We'll do that. We'll pretend that works.
Yeah.
Now we can connect the dots in a straight line. We've gone a little while. Okay, so there we go. So the first thing we did is graph the point, and the second thing we did is use the slope. If the slope was negative, let's say I said graph the point -1, 2 with a slope of -3, just -3. Let's try this. I'm going to clear the deck. Is this okay if I erase?
Yeah.
Okay. So -2, -1, 2. So first I start with the point, -1, 2. Now, if the slope is not given to you as a fraction, you absolutely have to make it a fraction, because then it's rise over, I have no idea. Okay, then next to the numerator, I'm gonna write rise. Next to the denominator, I'm gonna write run, just so I remember what each of those means. So if I rise -3, what do you think that means? Is it up? You fall 3, good. So I'm gonna go down 3, 1, 2, 3, over 1. Now I have room going in the same, 1, 2, 3, over 1. And I can go up 3 now, 1, 2, 3, over 1 to the right. And I have a nice line to draw. Yes.
Will you ask us like on future quizzes and stuff to plot more than 2 points on
It's just for fun.
Okay.
I like doing it. It's like steps. Questions? Please get started.